it's nice to know that there is a method for determining whether or not a graph has Euler paths or Euler circuits. We would look at the graph. First of all, it must be connected. They did not stress that in the textbook, but that is a condition that must be met. If it's a connected graph, you look at the vertices, you figure the degree of each vertex. If there's exactly two odd vertices, it has an Euler path. If they're all even, there's an Euler circuit. And if it's more than 3, game over, neither one. Sometimes they'll use the word neither. I'll kind of put that in quotes. The graph is neither. A few years ago, I had a student come in to class after we covered this, and the student said, all right, I'm having trouble. I got Euler path. I have Euler circuit. I got both of them. I don't know what neither is. Because the way they word the problems, it might be, does this graph have an Euler path, an Euler circuit, or neither? You know, is it neither? Well, it's not path, Euler path, not an Euler circuit, then it's neither. Let me make a little comment for about 1 and 2. We'll call this a little note. Every circuit is a path. The definition of circuit was a path that starts and stops at the same place. So on number 2, where I talked about Euler circuit, that's also an Euler path. We'll make a note about that. So if a graph has exactly, I'm going to go with number 1 first, exactly 2 odd vertices, then it has an Euler path, but not an Euler circuit. And if a graph has all even vertices, this is a connected graph. If a graph has all even vertices, then it has an Euler circuit and an Euler path. Sometimes in the homework, they'll talk about, they'll use that kind of language. Does this graph have an Euler path but not an Euler circuit?